Hello, awesome student. Let me introduce myself. My name is Ni Kadek Sri Damayanti, so you can call me that Sri. I'm from the program study of mathematics education, and this is going to be an amazing, incredible years because here are some of the things we are going to cover in my class. What's the topic? It's about sets, relation, and function. So what is set? A set is a collection of objects which are called the members or elements of that set. If we have a set, we say that some objects belong or do not belong to this set, are or are not in the set. We say also that set consists of their elements. Now, for the example of set is the set of students in this room, the set of natural numbers, and for not set example is an interesting collection of painting. Why? Because the meaning of word interesting varies according to each person. Set can be finite or infinite. There is exactly one set, the empty set or null set, which has no members at all. So a set with only one member is called a singleton or a singleton set. For the notation is A, B, C for set, A, B, C or X, Y, Z for members. So B is an element of A if B belongs to A, and B is element of A if both A and B are set and B is a member of A, and C is not element of A if C does not belong to A, and for the symbol is used for the empty set. Now for the specification of set. Number 1 is by list notation. For the example is A equal to, so when you write that, you must enclose with brackets. A equal to 1, 2, 3, and number 2 by predicate notation. For example is the set of all x such that x is a natural number and is less than x. Number 3, by defining a set of rules which generates or defines its member. For example is the set E of even numbers greater than 3 for element of E. If x element of E, then x plus 2 element of E. Nothing else belongs to A. Okay, now about identity and cardinality. Two sets are identical if and only if they have exactly the same member. So A equal to B if for every x is element of A, so x so x element of B. For example is 0, 2, 4 equal to the set of all x such that x is an even natural number less than 5. And cardinality, the numbers of elements in a set is called the cardinality of A, written like that or this symbol. For the example is A equal to x less than 6 and x is a positive integer. A equal to 5, 4, 3, 2, and 1. So the cardinality equal to 5. Why are zeros not included? Because 0 is not a positive integer and does not include negative integer. So zeros is neutral numbers. Okay, now about the subset. A set A is a subset of a set B if every element of A is also an element of B. Such a relation between set is denoted by if A subset B and A is not equal B, we call A proper subset of B and write like that. Caution, sometimes proper subset is used the way we are using subset. But sign can be negated using the slash or through the sign. Example, set of A and B, subset set of D, A, B, E, and set of A, B, proper subset set of D, A, B, E, and A, set of A, B, subset set of A, B, but a subset of A, B is not proper subset set of A, B. Okay, power sets. The set of all subsets of a set is called the power set of A and denoted as like that or sometimes as 2 grade A. For example, if A equal to a set of A, AB, so the power set of A equal to empty set, singleton of A, singleton of B, and set of A and B. Now about operation on set. Number 1 is union. The union of A and B, written A union B, is the set whose elements are just the elements of E or B or of both. In the predicate notation, the definition is A union B, the set of all X such that X element of E, A or X element of B. And number 2, intersection. The intersection of E and B, written A intersection B, is the set whose elements are just the elements of both A and B. In the predicate notation, the definition is A intersection B equal to the set of all X such that X element of E and X element of B. And more operation on set is difference. The difference A minus B, written like that, which subtract from A all elements which are in B. Also called relative complement, the complement of B relative to A. The predicate notation defines this operation as follows: A minus B equal to the set of all X such that X element of E and X is not element of B. And then complement A minus B is also called the relative complement of B relative to A. This operation is to be distinguished from the complement of a set A, written A accent, which is the set consisting of everything not in A. In predicate notation is A accent equal to the set of all X such that X is not element of A. Now about set theoretic equalities. Number 1 is idempotent laws, commutative laws, associative laws, distributive law, identity law, complement law, the Morgan's laws, consistency principle. Okay, now about relation and function. Okay, all function are relation, but not all relation are function. So you can see this picture. What is a function? A function is a relation which describes that there should be only one output for each input, or we can say that a special kind of relation, a set of ordered pairs, which follow a rule i.e. every x value should be associated with only one y value is called a function. So for the example is if x equal to 3 times x. So for domain is minus 1, 1 and 3, and for the range is minus 3, 3 and 9. So next, the type of function. Number 1 is injective function, surjective function, and bijective function. The difference of three function is a function. An injective function is a function that always maps the distinct elements of its domain to the distinct element of its codomain. And surjective function, a function that maps one or more elements of A to the same element of B, like that. And bijective function is a function that's both injective and surjective. It also known as one-to-one correspondence. Okay, then about relation. What is the relation? It is a subset of the Cartesian product, or simply a bunch of points or ordered pairs. In other words, the relation between the two sets is defined as the collection of the ordered pair in which the ordered pair is formed by the object from each set. Relation representation is a relation in table, relation in graph, and relation in mapping diagram. And now the types of relation. Different types of relation are as follows: empty relation, universal relation, identity relation, inverse relation, reflexive relation, symmetric relation, transitive relation. Okay, thank you. That's all about set, relation, and function. And I want to say, trust yourself. You know more than you think you do. From Benjamin Spoke. And looking forward to an awesome year with you all. Thank you.